Good morning, everyone. Thank you for joining us today and welcome to today's AIA training presentation. Today's topic is understanding your choices in reality capture. Our presenter today is Chris Mounts. He is the Director of Laser Scanning at PMC. Please note that your microphones have been muted to prevent any background noise throughout the presentation as it is being recorded today. If you have any questions, please utilize the Q&A button at the bottom of your screen. We will be holding a live Q&A session at the end of the presentation. So if you have your questions, those will be answered there. If you have any issues with sound or visual errors, also utilize the Q&A features. I'll do my best to help you as the presentation continues. As I mentioned before, the webinar is being recorded and will be uploaded to our YouTube channel later. So if you miss it today or you want to review it, it'll be recording up on our YouTube channel, and we'll discuss more about that at the end of the presentation. The last little bit of things I want to do before we start, I'd like to remind everyone to please provide your AIA number to receive your credits. If you don't have an AIA number, don't worry. You'll still receive a PMC certificate for attending the presentation today. Many of you have already provided your AIA number upon registration. However, if you didn't or can't remember if you did, you can just provide it in the Q&A area, or feel free to email me at bhubs@pmcorp.com. And I'll be sure to put that in the chat so you guys can see it. But now, I'll turn things over to Chris to begin our presentation. Chris, take it away.
Thanks, Brian. Hey, welcome everyone to the webinar today. And we will jump right in. So this is one of a series of learning classes we do, mostly around reality capture, even though we will actually be adding a brand new one shortly that's going to focus on simulating a pedestrian flow using digital twin technology. So that will be coming out in the next month or so. And for now, these are what we have. And today is going to be understanding your choices in reality capture. So real quick, we'll get through some of the background of who PMC is, just so you know that we're qualified to be talking today. Opened a long time ago. We're one of the largest laser scanning companies on Earth. We do thousands of projects, every style, shape you can imagine. I can't think of any particular thing that we haven't scanned at this point, from large to small. And then a lot of those we, of course, convert into different CAD outputs for people. We've got several offices scattered around the globe at this point, with our main ones being in Dearborn and Nagpur. And out of those, we have equipment stationed at several of those offices to support our clients with capture and field work. So kind of a short list of what we do here at PMC. Obviously, reality capture, that's why we're talking today. We also do industrial engineering, 3D modeling, Revit, AutoCAD, all that type of stuff, as well as simulation and visualization work. A little about me. I started my career in industrial and process engineering. Since then, I've moved into scanning and CAD work. I manage a large team, international team, about 100 people at this point. I've personally scanned, well over 100 million square feet. Well, PMC is really approaching 1 billion at this point. And we were one of the original people scanning a long time ago. And outside of here, I coach high school competitive robotics on the side. So why are we talking today before we kind of get into things? So, if we were talking, 15, 20 years ago, there really weren't choices in reality capture. There were laser scanners and that was it. There was one or two manufacturers back then. They did approximately the same thing. They worked in approximately the same way. Today, there's a lot of variation ranging from, scanning with your iPhone up through, really high precision and specialty equipment like explosion resistant scanners, and everywhere in between. So hopefully today we're going to go over some of that and help you understand, what is out there, what tech is out there, and how best to use it to get done what you need to do. Okay. So we're going to start here with a little bit about scanning and reality capture. Just make sure everyone has some of the fundamentals in line before we dive a little deeper. Then we'll get into some of the specifics of the equipment, that's out there today, what it does, what it's good at, what it's not good at. And then we'll jump into, some live data, including we'll go through what different point clouds look like that have been captured with a different technology, as well as a quick run through of the big names in the virtual tour space, since that's becoming a more important part of all the deliverables in this business. That we're gonna, cover some of the basics here. So, what is reality capture? This used to just be called laser scanning, and then it stopped being just laser scanning. There's different ways to capture data. Some involve lasers, some don't. But reality capture, at least for us, is really about digitizing the real world in any one of a number of ways. Right now, the two primary ways are going to be laser based and photogrammetry, right? Laser obviously being just that, a laser that leaves these machines and records data. Photogrammetry is the process of taking individual 2D photos that you take with a camera and then processing that data into 3D data using computer power to do that. One point before we get too deep into here, today we're talking about reality capture in the building scale. So there's things on both ends of that. There's metrology, reverse engineering stuff that we're not going to cover today. And then there's very large mobile mapping technology that we're not going to cover today. So we're going to focus on the type of technology that's out there to record buildings, campuses, things on that scale. Right. So color versus black and white. Different devices may not be capable of color capture, or color capture is optional. So anything that's doing a laser is not capable of capturing color information about the real world. It's only capable of capturing intensity data about the world. And so you end up with these grayscale point clouds from some devices. So just keep in mind that color is a secondary capture. It's done using cameras that are built into the most modern scanning devices, although some of the mobile stuff doesn't have a camera. And it does produce different data quality. And more today, the quality of the image and the color capture can be sacrificed a little to speed up the overall data capture. So some devices can run much, much faster if they take lower quality photos, which obviously if the device is running faster, it's going to ultimately reduce the cost of the capture. Hey, so, when we talk about the going out there and doing the reality capture, the way it gets done is that you start with a plan where you've gone through everything, and we have a whole separate presentation on contracting out services and what to expect. But the plan is going to be important, right, to get everything on the right track, and then you're going to go to do your on-site scanning. This is or drone work or photogrammetry work, whatever it is you're doing. You're going to complete the on-site work. Then there's another part that's going to happen with most of this work, which is the registration or the post-processing work. No matter what capture technique is used, there's almost always some post-processing. The only exception is on smaller work now, 5,000 square foot and below jobs. Those can be post-processed live on site. And so when the operator leaves the site, the data can be ready to go. On projects any larger than that, there's complications that usually means you can't do the on-site post-processing. And then once that's done, you're going to need to generate likely some outputs. So whether that's virtual tours or point clouds for use in CAD or some analysis data, that's going to be done on top of that work. So Now, if we talk fixed scanning, so this is a scanner that goes on a tripod. We're seeing one here over on the right. Um, these are individual scans. Nowadays, these scans can range from anywhere from 30 seconds to 15 minutes or even more per scan. You're going to need to do 4 to 5 scans per 1,000 square feet in most sites. Obviously, that can vary a lot depending on the breakdown of the space. If you have a lot of very small rooms, that number can go much higher. If it's a big open warehouse, the number goes much lower. Um, in all scanning and all capture in general, it's best to do it when the site's not active, when there's not people there. So sometimes that can mean, in the evenings or after hours or holidays or whatever it might be to get there and capture when there are not people walking around. That doesn't mean you can't do it when people are there. You certainly can, and we certainly do a lot of that. It's just the data will be better if it's empty. Um, as the projects get larger, you're definitely going to need to do targets. This is where a lot of projects fail, is that people think they can use some of the cloud to cloud registration on projects that are too large. Um, it's not going to end well for you if you do too big of a project without targets. And then for some of the more complicated projects and larger projects, you may want to consider installing permanent benchmarks. These allow for multiple trips to be done and for the data to stitch together perfectly between them. Also, as the projects get very large, you're going to need to do traditional land survey to keep the data quality high. So with fixed scanning, like I said, for the very small, you can do on-site registration and upload the data live from the site. If it's a project of any substance, large size, you're not going to be able to do that. So there's going to be some work back in the office. Predominantly, that's going to be registration. And that's the work of connecting each individual setup, like we saw in that video, back together to generate one unified point cloud. Right. So a point cloud could include, anywhere from, I guess, one scan up to thousands of scans can be combined into one point cloud. And these are, individual observation points within the space. And one thing to keep in mind is that depending again on the exact scope of the project, this takes time. Um, Anywhere from, as little as a day if it's a smaller project, up to weeks if it's a very large, complicated project. And very difficult sometimes to throw more resources at it because at some point you're usually locked into a single computer that's got to process a huge amount of data, and that can take an extensive period of time. So now moving into mobile or SLAM units, they're called. These are wearable or handheld units. And the difference here is where in the terrestrial or tripod based, you were locked in to one location and you'd run a scan and then you'd pick up your equipment, move it, and run another scan. Here you're just walking through the space. And the units are using SLAM algorithms to lock in the coordinates of where you are in real time and then create a 3D map of the space. These devices capture huge volumes of data very, very quickly. 10,000 square foot an hour would be on the medium to low end of capture. Right, it's essentially as fast as you can casually walk through the space, you can capture it. The difference in why this isn't the predominant technology is really two things. One is the accuracy is a little lower than the tripod-based scanning. And then the other thing is to get good quality data on larger sites is actually a very complicated thing to do and requires people involved that know how to use the technology correctly. It's very easy to get very bad data out of these devices if you do things wrong. So the registration process, it's not really a traditional registration process, but you're typically going to end up with multiple data sets. You can only walk around with these things for so long before you have to stop and start a new data set. So there is some work in stitching those together and other quality control things that go into that. Um, the other thing to consider is that most of these mobile solutions require cloud-based processing. And this can add up to a pretty substantial cost. So, versus where on the terrestrials right now, at least there is on-premises processing. The SLAM stuff is almost always going to be cloud-based, and you have to pay what that costs to get the work done. Alignment is something I want to talk about, and this is so critical. Again, we have an entire class devoted to alignment. But in the basic terms, if we talk about fixed scanning, tripod scanning, what happens is the very first scan someone does, the center of that scan at the scan head becomes the 000 point of the data set. And whatever direction that scanner just happens to be pointing becomes north. So obviously, in most cases, that is not usable data, and we need to do alignment, right? And alignment's going to consist of establishing level. This is handled entirely by the scanning provider, not something you need to concern yourself with. The origin point, or the XY location of the data, the elevation of the data. Do you want finished floor to be at 0 or at 100 feet? And then finally, your rotation, right? Which way do you want this data to point? And don't take any of this for granted when you're doing this process. If you screw the alignment up and it doesn't match up to your expectations, all of the post-processing work that on bigger jobs can take weeks has to be completely redone to adjust the alignment. So make sure you spend some time, make sure you agree on what's our origin point, which way points north in the building, and where do you want your elevation? And then importantly, what point is your origin point and what point is your elevation going to be set to? Because in the real world, nothing matches what was designed in CAD. Your building grid will not match real life. Your building corners, even if you have the building traditionally surveyed, will not match because that data is much less accurate than scanning. And then elevation floors in real life are never flat. They're never even. So where do you want those points to be? So now we get into outputs. Three primary types of outputs are generated from scan data. Point clouds, the scan data that we're going to look at in a minute. CAD data, which is essentially tracing over top of the points to generate CAD data. And report data. This could be any kind of analysis, level, flatness, deflection, those types of things can be put out. Lots of different formats are available, various reports, those types of things can be generated. Okay. So one thing I wanted to talk a little bit about, this gets some people confused, and this video shows it kind of. We're going to start here with a look at a point cloud, right? And you can see it's a bunch of little dots, right? And it can look good. It can look like a photograph, but ultimately most projects need the model to be developed, right? 3D workable parametric geometry that you can create your future design or construction documents from. There are use cases where you can get by with just the model or just the point cloud. Maybe it's, project coordination, things like that. But oftentimes you really need to get the CAD model developed, and that is a separate step from the scanning step. Okay. So, as I mentioned, one of the big outputs nowadays is virtual tours. These are becoming increasingly important and increasing part of the request, and also leading to a lot of confusion over what exactly they are, what options there are. In general, although there are some interesting ways you can translate data back and forth, the virtual tour that's going to be available to you is dependent on the capture equipment used to capture. So in the case of, let's say, Faro equipment, or you're talking WebShare. In the case of Naviz mobile equipment, you're talking Ivion. And in the case of Matterport, you're talking Matterport virtual tours. They say there are ways to exchange data back and forth, but none of them are perfect. And you're going to get the best experience using the native virtual tour platform. And all of the manufacturers have their own platform. Okay. You can see from here, right? Most of these are now cloud only solutions for hosting. So if that's a problem for you, you have to consider that. Some can support VR, some don't. Some have different levels of measured accuracy. However, I will say in general, no virtual tour provides very good measured accuracy in comparison to CAD. And then just the visual appeal, right? How enjoyable they are to use, how user friendly varies quite a bit. You know, with I would say on the low end, you're at the WebShare or the Leica solution. The Naviz solution is better, and then the Matterport being the best because that's that company's primary focus is virtual tours. So now we're going to jump into the equipment choices and go through what's out there on the market today and how it gets used. And start with, this is a question that we ask, to our clients in one frame or another when we're bidding on work, right? What is the problem you're trying to solve, and will the data that we're going to capture solve that problem without going overboard? Right. So if you have a very small space and your dimensional requirements are pretty simple, Matterport might be your best choice, right? It's going to be very cheap to execute. We're going to be able to do it very quickly. But if your capture is 100,000 square foot manufacturing space, I would definitely not recommend Matterport. So we want to make sure that we align the equipment choice with how the data is actually going to be used. Right. So when we look at different data and some of the levels of accuracy has been defined by our trade group, the USIBD. In general, where we operate, again, on, we're talking today about the building scale or the campus scale stuff. We're going to be in the LOA 30 to LOA 40 range. And your terrestrial tripod-based scanning is going to be the tightest, and it's going to fall in that LOA 40. And in particular, it's going to fall in the, the 1 to 3 millimeter range in the LOA 40. Sort of smack in the middle between 40 and 30 is going to be the high quality mobile units like the Naviz, which is going to be right around that 5 millimeter when done correctly. Again, I can't stress that enough, when done correctly for all of this data. Very easy to create tripod-based data that's screwed up by feet. But if you do it right, you can get it down to the 2-3 millimeter range. And then sort of at the upper end of the 30 is going to be the drone-based photogrammetry data, or any drone-based laser or photogrammetry. Even though laser is probably going to drift more into the 20 at this point. But you can get some pretty good results, again, when done correct. So another thing to consider is accuracy versus resolution. And so when you look at some of these machines, they claim ranges that are, 300 meters or more. And that's great. They can actually shoot a laser that far and get data back that far away. However, the thing to keep in mind is that the resolution is defined as, how many points per square inch at 10 meters away. So if you then project that density out to 300 meters, right, all of a sudden you may have a point every 6 inches, every foot. or less. So in often cases, the practical capture versus the advertised resolution on the machine are going to be two very different things, right? I certainly wouldn't expect to be able to model a building facade by running the scanner from 300 meters away. That would be a big challenge, right? Because we're going to start to miss all kinds of detail when we have it that far away. That said, on the other hand, if you have it too close, you start collecting way too much data and your data sets become very large. And while there are ways to clean that and do reductions in point count, it's still not a great place to be. You don't want to run it way too high. So, what are some of the practical differences between the machines, right? We touched on this a little. I would say, in the first one, we're showing Faro units, but there's a whole bank of these traditional tripod-based scanners. These include the Faros, the Leicas, the Trimbles, ZNFs, and there's a few other Regals, another one, manufacturers of this equipment. They're all about the same. I'm sure their salespeople would love to explain to you how they're very different, but in practical terms, they're really not. I would say, the practical range of these is going to be about 50 feet. Again, that depends on really what you're doing, right? If you're a civil guy capturing, giant sites, the practical ranges are much bigger. But if you're capturing buildings and campus type stuff, 50 feet, give or take. And same with the, Naviz mobile units, the higher quality mobiles. The speed has gotten better on the tripod based stuff, but it's still nowhere near the speed of the good mobile stuff. Then we move into the handheld mobiles. These are incredibly fast, but the ranges are limited. And the accuracy is suspect. I would say it's actually pretty hard to quantify even what the accuracy is on those units, but they do have their place. Drones and photogrammetry, we're using this more and more because I'd say, now we're seeing results. The software has gotten much better. And again, when done correctly, we're getting sub 1 inch accuracy, down close to the half-inch accuracy in some of this stuff. And so we're using it for sites, roofs, and building facades now. And then lastly, we have the Matterport stuff. This has gotten better with the latest generation of Matterport scanner, but it's still, accuracy is measured as a percentage of distance, which gives you a general idea of how that would work, right? If you're plus minus, 0.1 inch at 10 feet, you're plus minus an inch at 100 feet. And it gets kind of worse from there. Yeah, and so I think, this is good for smaller projects. So looking at, the terrestrial, the tripod-based stuff, this is the oldest technology in this business. It's the one that's used the most still. Just reliable, high accuracy stuff. Nowadays, this is very easy to use, especially on smaller projects where you can do cloud-to-cloud registration. Those jobs are going to go smooth. You don't need a ton of experience with using them. They also have, the most, I would say, robust processing and back-end support, data interoperability. So, you can process Leica data with Faro software and vice versa. Most flexibility here in what they do, but they are a little slower than certainly than the mobile units. But they definitely still have their purpose. And so, the larger mobile units that I mentioned earlier, these are mostly at this point limited to the Naviz. There's not many other competitors out there in this space right now. These are going to be used on larger projects, and because of that, they do require survey control. I don't exactly know where the threshold is, where this data is going to become unusable, and it varies a lot by the site and the specifics and how overlapped the data is and how mixed it is. But most of the time you're going to need those control points to be shot in by a surveyor. There are in some cases access issues. You do have to wear this unit. So if you can't fit in the place you need to scan, well, it's not going to work. At least a fast capture rate. And this is, of course, color data with the NavIs. Handheld mobile units. This is predominantly, there's a Leica solution and a GeoSlam solution that actually just got purchased by Faro. These are pretty niche market kind of things. Because the price point on these is not that much different than a terrestrial or a tripod based scanner. But there are markets where these can make sense. They are SLAM based, they are fast, but the data quality is just not what I think a lot of people would expect out of modern laser scanners. Drones and photogrammetry. So you can put a laser on a drone, and we're seeing improvements in that data, in particular solution from Leica that's better. But what I will say is I have not seen drone-based laser data that is better or even comparable to the photogrammetry data that is being produced today with the top of the line software that's out there. It does have its purpose, right? Laser-based drone work is good for survey work and punching through tree canopies and things like that to get to the ground, where photogrammetry can't do that. But for the most part, putting a laser on a drone, if you're in the building business, is not something you need to consider at the moment. And the other thing here is photogrammetry is getting better and better and better. And it's starting to debut on interior work as well as exterior. And like I said, the quality of the data is quickly approaching that of laser scan, traditional scanning data. And I would keep an eye on this business, if you're interested in this stuff, as this is where a lot of the really advanced development is coming into play. Essentially, photogrammetry Matterport is a strange hybrid. It's somewhat scanner based, somewhat photogrammetry, sort of a hybrid solution. Lower accuracy but extremely fast capture. Great virtual tours, right? Best in class virtual tours. This is absolutely dominant in the real estate market. Half the homes you would look at for sale are going to include Matterport virtual tours. A lot of options in here as far as subcontracting this work out, things like that. Just keep in mind its limitations on size and the data you're going to get out of it. Data hosting and processing. This is becoming a more interesting part of the business, just because the cloud solutions cost money. And that money has been going up lately. So whereas the local processing costs have stayed pretty consistent, what these companies are charging for the cloud-based hosting and processing has been going up and becoming more expensive. So it's something to consider. And actually, I need to update the slide. There's a few mistakes in here, so I'll go through it real quick. Terrestrial, you have both cloud and local options for processing, cloud and local options for the virtual tour hosting. And the cost can range from, if you're doing it yourself, it can be very cheap, up to pretty costly when you're using their systems to process. And the manufacturer can be the governing force in that, some being on the lower end, some being on the more expensive end. apologies, there's a typo here. On the mobile units, particularly from NavIs, okay, processing at this point is 100% cloud-based. You do not have a local option. Same with hosting. They've removed the local option. I believe with NavIs, if you are an extremely large client, this is negotiable. But for most of us, it's cloud only. And it's a pretty expensive solution for both hosting and processing. The handheld mobiles, similar thing to actually the terrestrial stuff. They can be done local and remote. They don't have their virtual tour support is a little sketchy at this point, but processing can be done local and hosted. Drones, same thing. There's some really good cloud solutions for processing that make the process extremely simple. Whereas the higher end, higher quality solutions are run local right now, and require, large compute resources. And then hosting, similar deal. There's some really great cloud solutions out there, and there's local solutions. And the nice thing about the photogrammetry drone solutions is there's a ton of competition, meaning pricing is extremely reasonable for both local and hosted. Matterport, cloud only for both. And then hosting and processing has been getting a little more expensive over the last couple years, but it does drop as your volume goes up, and it's still one of the more reasonably priced options out there. With that, we're going to jump into some live data review and look at, actually, I'll switch it up a little. We're going to start with looking at the virtual tours and what the different solutions offer in that space. And then we're going to go into looking at the point cloud data in a CAD environment to see what you get and how you work with it. Okay. So let's start with the least attractive version of this. Jump into a project here real quick. So you can see all of them. Most of them are going to start with a map and let you see different things. All right. And then we can zoom in. And in here, we're looking at terrestrial data. So each one of these little symbols represents where an individual scan was done. And we can jump into that. All right. And take a look. This one's a bit of a mess because this one's been tagged with all the asset information. So let me just shut it off, clean it up a little bit. And we can see where all the individual scans were done. Tighten this up a little more. Okay. And we can take measurements in here, and the measurements are going to be pretty accurate. We can jump between different locations. All right, and take a look at different setups. You can notice here, right, we're pretty locked in to where the scanner was set up. Right. We can navigate around. One nice part about this is, this is, I believe, only available in Ivion and WebShare right now, is that you can actually export the point cloud data directly from this viewer, meaning you can pick and choose a working data set of point clouds. You'll get an email about an hour later, and then you can pull that into CAD to work on it. Jumping over to Ivion. And again, you're going to have the map to kind of geolocate this stuff. We zoom in on the project. Right. And this is, I think, a little nicer. It's a step up from WebShare as far as the user experience goes. Right. And we can navigate around the space. You will notice in here, right, that there's some difficulty. Almost all of these suffer from understanding floor levels. And you can kind of jump between floors without really meaning to. In some of them, they handle it a little better than in others, right? So over here, I've got my floors that I can jump between. Right. But pretty smooth setup. There's also some good virtual tour tools within here where you can actually build out, all kinds of smart data tags and points of interest and embed videos and web content in here, all to kind of buff up the virtual tour, or maybe you're using this for facility management, all those different things you can do through here. Okay. And lastly, we're going to jump into Matterport space. I think visually, this is the nicest tool that's out there. Right. Camera quality is very good, very easy to navigate, very smooth. Right. And again, also in Matterport, you're going to have very advanced kind of virtual tour tools where you can build out all kinds of points of interest. You can map out walk paths if you want like a guided tour. You can add labels, dimensions. You can do all kinds of interesting things, add notes and tags. And then both Matterport and WebShare support VR, whereas at the moment, we believe Ivion does not support VR, if that's something that you're concerned with. Okay, so that's kind of a high-level overview of the different web platforms. All these companies have public data sets available you can go check out and play around with as well. And so with that, I'm going to jump into what this stuff looks like in CAD. So what we were looking at there was really the photographs that were taken. We weren't really seeing the point cloud data. Now, if we do, and we can switch back to that, but we looked at the point cloud data from a single scan point of view with the tripod-based scanning, what you're going to see is an incredibly dense measured point cloud that almost look like a photograph. But when we register those individual scans together to build our project point cloud, and then we want to pull that project point cloud into CAD, that data needs to be downsampled. So it's not going to be as dense, it's not going to be as thick of the point cloud data as what we were looking at in the web viewer. Right? So that we're just going to start with a data set, right? So this is the CAD model, right, which is going to look like a Revit model. It looks good. But let's turn on some, we'll start with the terrestrial scan data. So the tripod-based stuff. So this is our interior look, right? And you can see, right, obviously this is heavily downsampled. But it's still, obviously you can tell what things are. And if you were in CAD, if you were in AutoCAD, Revit, MicroStation, whatever you were in, this is what you would see in the CAD program. It would look to this level of detail, and then you would model on top of it. Right? The only thing I'll point out is, so this is that tripod-based scanner data. And depending on the exact manufacturer, this is one thing where the manufacturers vary a little. The quality of the color capture can vary, which translates into what you see in this view. Like to me, this view is a little washed out. It's got a little too much white in it. And we look at the Navis data in a minute here, you'll see that it looks better. You also notice some stuff that these scanners are prone to, these artifacts that sort of pop up, right? These kind of stray points, and there's ways to clean those. We're showing kind of the raw data, to give you an idea what you're really going to get off the scanner, as well as, each scanner has some problems picking up different things. All of them, any that do color capture, or that use lasers, I should say, can have some problems around really dark matte finishes, and very reflective finishes. Reflections can cause problems in the data set. And then you'll also notice, areas there wasn't a scan done in here, so we've missed all the underside of these desks, right? So they're we would call those occlusions, things that are blocked from view when the scan was done. Let me turn on next. We'll look at some VLX data. So this is NavIs data from the mobile unit. Okay. In general, like I said, I think the color capture is much better in this data set. I think NavIs does some nice data cleaning. This data just looks a little cleaner. But it too has its issues, right? It clearly had some problems with this metallic color on these mullions. And capturing it correct. But overall, a nice clean data set, right? In this data we're going to be we're looking at right here, dimensionally, let's say, from this wall over to the opposing wall, you're going to be worst case, absolute worst case, probably a 1/4 inch. In here, it's probably even tighter. When we were looking at the tripod-based data, even though it looked a little messier, it is more accurate. So you're going to be looking at about 1/8 of an inch between the two faces of the wall. And then in both cases, when jobs are done correct, you can hold those kind of tolerances on massive projects too. Okay. Let's look at a little of the handheld data here. And one thing I'm going to say about this is there are newer handheld units that have come out since we last ran this data set. We try to keep up on stuff, but this is a little outdated. This in particular one was done with the Leica BLK to Go, which I've been told does a much better job than this. But I'll believe it when I see it. I think these mobile units have some issues that are being worked through. That said, right, it did capture things. I mean, it's easy enough to, despite the kind of abstract nature of this, you can see the information and you could make an accurate plan from this. It's not nearly as dense as the other data, and there's some strangeness here, where you can see the actual trace lines of the laser going through things. The color capture is not great, but at least it has it. Some of the other handheld units have no color capture at all. They're only intensity based, so grayscale. Right. But overall, it's workable, and you could get a job done with it. Jumping over, looking at some terrestrial or some photogrammetry data that was done up on the roof of the building. And this is some older data. This processing has gotten better since this was done. But again, this is done in a few minutes of a drone flight. And this data is certainly good enough to model the roof on this building, including, getting the air handlers sized right, getting some of the mechanical and electrical routed correctly. Overall, it looks pretty good. Okay. One last thing that we haven't touched on yet that is important to a lot of people is scanning above active ceiling systems or drop ceiling systems. Right now, the only way that I would recommend doing this work is with tripod-based scanners. And so you can combine the tripod above ceiling with the mobile units below to sort of maximize efficiencies there. But for some jobs, especially in commercial stuff, right, getting above the drop ceiling is very important. And that's, like I say, done with terrestrial scanners, where we pop a ceiling tile, stick a scanner up into the ceiling space and capture it. A lot of technique, a lot of skill goes into actually getting this data. But it certainly can be done and is done every day, right? And it can provide some interesting stuff. We talked a little about the mobile units, right? If you can't fit, you can't capture data there. And above drop ceiling would be the perfect case for this. You can do it with those handheld units to varying degrees of success, but it will not be very accurate. But this can capture that, difficult to get information that's above the drop ceiling. But, again, you're limited in the technology you're using to capture this. And then the last thing I want to wrap up with is a different data set here. But this is just give you an idea of what Matterport data that's exported looks like. Again, Matterport's a very different technology. There's a few different devices, although Matterport's the biggest name in it. But it's going to give you an idea of what this looks like in CAD. So overall, the data is good. It's certainly adequate in most cases, given the size to generate a plan view. You'll notice a lot more occlusions, a lot more missing data, more types of data that it can't capture, colors, things that interfere with its ability to capture, and some general oddities in the data. Some weird patching on walls and things. You also notice it can look at a distance, and as you zoom in, it's pretty light data, meaning there's not a lot of resolution to this data. As we look around, right, overall, though, like I say, it's certainly not bad, and certainly adequate in a lot of cases for generating basic plan views. But what you're not going to do with this is get detail on handrail and stuff like that. That's definitely not something where this technology is going to work for you. And with that kind of wraps up today's presentation. We've covered the live data, we've covered the virtual tour stuff, and with that, I'm happy to answer any questions that people might have.
Yep, thank you, Chris. So as Chris just said, if you have any questions now that the presentation is ended, we're holding a live Q&A here. So if you have any specific questions for Chris, please go ahead and use the Q&A button at the bottom and submit your questions, and we'll have Chris address those for you. So with that, the first question that came in, Chris, is what is the limit/cutoff for cloud to cloud scans, or what is the max size?
It's really a sliding scale of losing control of accuracy and what your tolerance for that is. If you're interested in holding that 1/8 inch tolerance, you're somewhere around 25,000 square feet, probably, maybe even a little smaller to hold that. Right, cloud to cloud just does not hold accuracy the way that the artificial targets do, and then beyond that, the way that survey control does.
Oh, sorry, Chris. I was muted. The next question we had, and this came via email actually. So, but the question is, have we done scans for existing car dealerships before?
Yep, several.
Okay. Thank you. And then the next question we have, do you know what system Google uses?
Oh, for like the Street View thing?
Probably.
Purely photo based, and what they're doing now, like they just announced some advancements in photogrammetry to generate the 3D models from the 2D, right? But I mean, in all that, you're really talking about the mobile mapping scale, not the building design and engineering scale. So the individual photos obviously look good, but they're not, the geometry behind it, the 3D accuracy of the data they collect is exceptionally low, and too low for most building applications.
Okay, so thank you, Chris. The next question is, should survey controls be set at the beginning of every scanning project? And if so, if you do not set it, how difficult is it to line up the scans?
So this is relative to the size of the project. We, here at PMC, if it's a smaller project of 10,000 square feet or below, something like that. We do not use any secondary survey control. We just scan cloud to cloud registration, and then we do manual alignments based on that. As they get bigger, we of course do the first targets and then survey control. And what I can say is it's more difficult to align when you don't have survey control. It's also less accurate to align, and it can cause some issues. But there is just an initial cost in running survey control that the smaller projects can't justify.
All right, thank you, Chris. The next question, someone's giving you a shout out, says, great presentation, thanks. But it does then say, if one was to forensically measure something like a floor flatness levelness, where the specified flatness is 1/8 of an inch in 10 feet, what resolution could be used for the scan and what equipment would you recommend? This is not directly related to the presentation, is what he was saying. So
I
if you
mean, it
need me
is
to
right. I
read,
mean, we do some of this work, right? I think this is going to depend on. I hate to keep saying this, but the size of the project. In general terms, right? You're going to be in the to do floor flatness. You're going to be in the tripod-based scanning world, and within that world, sort of at the low end, both in terms of cost. And importantly to this question, in terms of holding level, is going to be the Faro units. At the high end of that is going to be the survey grade Leica units, not the cheap ones, the good ones, the P60s, the expensive heavy equipment. Those are going to hold level over incredible distances. And so, with the Faro, you're going to be somewhat limited to how tight you can hold level without running secondary survey control. You can use Faro, run survey control, and do any size job you want to hold level. But the Leica units are going to let you run, both are going to let you run level because they have total stations built in, but they're also going to hold level over really large areas. And then as far as, resolution, that's just dependent on what your requirement is. You're definitely going to want enough captured data to make sure that you can identify that the point you're measuring isn't like a candy wrapper that was left on the floor, right? So you're going to want at least enough to see that kind of information. But in most cases, a relatively low res scan works fine for that. It's more in terms of, have you held level accurately?
all right, thank you, Chris.
Yep.
With that, I don't see any further questions coming in at this time. So with that, I'll close the Q&A. If you want to check out other upcoming presentations that PMC has given, please be sure to go to our website at www.pmcorp.com. Click on the resources tab and scroll down to webinars and events to register for any other upcoming webinars. As I mentioned before, this webinar is being recorded and it will be uploaded to our YouTube channel probably sometime later this week. If you want to check that out, go to YouTube and search PMC videos. It's videos with an S and all of one word, to view other potential topics, and including this one when it goes up. If you want to check it out, review the slides, we recommend you do that. Before we conclude today's webinar, I'd just like to kind of reiterate the point about the AIA certificates. If you provided your AIA number and you attended this presentation, you'll receive your credits via certificate. If you do not have an AIA number, don't worry. Like I said before, you'll still receive a certificate via PMC. But if you don't recall, if you provided me with your AIA number, I did provide in the chat my email address. And that I'll just say it again for you now, but it's bhubbs, that's BHUBBS at pmcorp.com if you want to share that with me to make sure you get your AIA credits. But with that, that'll conclude today's webinar. So I'd like to thank everyone for your participation and attendance. We look forward to working with you or perhaps meeting you at another one of our webinars down the road. But with that, thank you and have a great day.